The atomic bomb represented humanity's most destructive invention, fundamentally reshaping warfare, international relations, and human consciousness. The development and use of atomic weapons during World War II initiated the nuclear age with consequences persisting to present day. The atomic bomb demonstrated science's capacity for unprecedented destruction, while raising profound ethical questions about technological progress and military power. Understanding atomic bomb history illuminates 20th century's transformative events and contemporary nuclear threats. Nuclear physics research initiated atomic bomb development. Marie Curie and Pierre Curie discovered radioactivity in 1898, establishing that atoms possessed internal energy. Ernest Rutherford discovered atomic nucleus in 1911 through gold foil experiments. Rutherford proposed that atoms could be split, releasing enormous energy. Niels Bohr developed atomic theory, explaining electron behavior and nuclear structure. Otto Hahn and Fritz Strassmann discovered nuclear fission in 1938, splitting uranium nucleus and releasing tremendous energy. These discoveries established scientific foundation, enabling atomic bomb development. Nazi Germany's threat motivated atomic bomb research. Germany developed advanced rocket and weapons programs. Germany possessed substantial scientific talent, including refugee scientists. Nazi ideology promoted military technological advancement. Western nations feared Germany could develop atomic bomb first. This fear motivated Allied atomic bomb research intensifying. American and British leaders recognized atomic weapons' potential military value. The possibility of Nazi atomic bomb drove atomic research urgency throughout World War II. Émigré physicists warned American leadership about atomic bomb possibilities. Albert Einstein, Leo Szilard, and other refugee scientists understood nuclear fission's implications. Szilard drafted letter warning President Roosevelt of atomic bomb possibilities. Einstein signed Szilard's letter in August 1939 warning Roosevelt that Germany might develop atomic weapons. Roosevelt received letter recommending American atomic bomb research. Roosevelt established Uranium Committee investigating atomic bomb feasibility. American government gradually mobilized resources for atomic research. The Manhattan Project represented unprecedented scientific and industrial mobilization. General Leslie Groves directed Manhattan Project in 1942. J. Robert Oppenheimer became scientific director, recruiting top physicists worldwide. Manhattan Project employed approximately 130,000 workers across multiple secret facilities. The project cost approximately $2 billion in 1940s currency, extraordinary resources for single military project. Manhattan Project's secret cities, including Los Alamos, Oak Ridge, and Hanford, were constructed in wilderness locations. Scientists worked in complete secrecy for years developing atomic weapons. Los Alamos Laboratory became Manhattan Project's scientific heart. Oppenheimer assembled greatest physicists of era at Los Alamos. Scientists from multiple nations collaborated on atomic bomb development. The intellectual environment at Los Alamos was extraordinary despite secrecy and isolation. Scientists were motivated by fear of Nazi atomic bomb and scientific challenge. However, many scientists harbored doubts about building atomic weapons. Ethical concerns emerged as scientists contemplated weapons destruction potential. Uranium enrichment proved technically challenging, requiring innovation. Fissile isotope enabling chain reactions comprises only 0.7% of natural uranium. Enriching uranium-235 to weapons-grade concentration required separating isotopes, extraordinarily difficult technically. Oak Ridge facility developed electromagnetic and gaseous diffusion enrichment processes. Thousands of workers operated enrichment equipment. Enrichment technology development consumed substantial Manhattan Project resources. By 1945, sufficient uranium-235 was produced for atomic bombs. Plutonium production provided alternative fissile material, could be created in nuclear reactors through neutron bombardment of uranium-238. Hanford facility developed plutonium production reactors. Plutonium chemical separation proved extremely challenging and dangerous. Plutonium processing exposed workers to radiation hazards. Some workers received lethal radiation doses unknowingly. By 1945, sufficient plutonium was produced for atomic weapons. Plutonium's creation through human technology was revolutionary and frightening. Bomb design and assembly presented additional technical challenges. Physicists developed two bomb designs: gun type using uranium-235 and implosion type using plutonium-239. Gun-type bomb accelerated uranium-235 projectile into uranium-235 target, creating chain reaction. Implosion-type bomb used conventional explosives, compressing plutonium-239 core to critical density. Implosion design proved more efficient and reliable. Scientists conducted extensive calculations and experiments developing bomb designs. By mid-1945, both bomb types were ready for deployment. Trinity test demonstrated atomic bomb's awesome destructive power. Manhattan Project scientists conducted first atomic bomb test on July 16, 1945, at New Mexico desert. Scientists were uncertain whether chain reaction would propagate. Bomb might fail or might devastate New Mexico. At 5:29 a.m., Trinity bomb detonated with force exceeding 20,000 tons of TNT. Explosion created blinding flash, intense heat, and massive blast wave. Radioactive mushroom cloud rose to 40,000 feet. Scientists witnessed atomic bomb's terrifying power firsthand. Oppenheimer later recalled thinking of Bhagavad Gita verse, "Now I am become death, the destroyer of worlds." After Trinity test, military leaders pushed for bomb deployment against Japan. Japan still fought fiercely despite Germany's surrender in May 1945. American military strategists estimated that invading Japan would cost hundreds of thousands of American lives. Atomic bomb offered alternative to costly invasion. President Truman authorized atomic bomb use against Japanese cities. Military leaders believed atomic bombs would end war quickly. Scientists who opposed atomic bomb use were ignored by military and political leadership. Hiroshima bomb detonated on August 6, 1945 at 8:15 a.m. Colonel Paul Tibbets piloted B-29 bomber Enola Gay carrying uranium-235 bomb. The bomb detonated 600 meters above Hiroshima city center. Explosion generated heat exceeding 3,000 degrees Celsius. Approximately 70,000 people died instantly. Blast destroyed 70% of buildings within 2-kilometer radius. Survivors suffered severe radiation burns and injuries. Entire city was devastated. Japanese government initially underestimated destruction severity. Nagasaki bomb detonated on August 9, 1945 at 11:02 a.m. Boxcar B-29 bomber carried plutonium-239 bomb. Nagasaki's mountainous terrain limited blast damage compared to flat Hiroshima. Approximately 40,000 people died instantly. Combined with subsequent radiation deaths, atomic bombs killed approximately 200,000 people by year's end. Radiation sickness killed thousands in following months and years. Survivors experienced severe health problems, including cancer, throughout lives. The destruction was almost incomprehensible in scale. Japan surrendered on August 15, 1945, approximately 1 week after Hiroshima bombing. Emperor Hirohito announced surrender, citing new and most cruel bomb. Historians debate whether atomic bombs or Soviet military entry into war Pacific theater convinced Japan to surrender. Japan's military leaders considered continuing war despite bombs. Soviet Union's declaration of war against Japan on August 8 came between bombings. Either factor alone might have compelled surrender. The combination of atomic bombs and Soviet entry made continuation impossible. Atomic bomb use created immediate moral and ethical crisis. American public initially celebrated war's end. However, as destruction scale became apparent, moral questions emerged. Killing 200,000 civilians, including women and children, raised profound ethical concerns. Many questioned whether atomic bombs were necessary for Japanese surrender. Scientists who built bombs experienced intense guilt and regret. Oppenheimer opposed future nuclear weapons use. Leo Szilard, who warned Roosevelt about atomic bomb danger, opposed using atomic bomb against Japan. International community established United Nations in 1945, partially responding to atomic bomb threat. Atomic weapons demonstrated humanity's capacity for self-destruction. International cooperation appeared necessary preventing nuclear war. United Nations attempted international governance, preventing future atomic bomb use. However, nuclear weapons remained military assets. Nations possessing atomic knowledge pursued weapons development. International control of atomic weapons proved impossible. Soviet Union developed atomic bomb in 1949, ending American atomic monopoly. American leaders believed Soviet atomic bomb development would take longer. Soviet scientists accelerated development through espionage, acquiring American technological information. Soviet bomb tests shocked Western world. Nuclear weapons were now possessed by two hostile superpowers. Arms race began immediately. Both superpowers pursued continuous weapons development seeking superiority. Hydrogen bomb development represented escalation beyond atomic bombs. Physicist Edward Teller advocated hydrogen bomb development. Hydrogen bombs used atomic bombs as triggers, creating thermonuclear reactions. Hydrogen bombs were thousands of times more powerful than atomic bombs. Soviet Union developed hydrogen bomb in 1953. United States developed hydrogen bomb in 1954. Hydrogen bomb development appeared to have no limits. Scientists warned that nuclear weapons could destroy civilization. Nuclear weapons proliferation increased through Cold War. Britain developed atomic bomb in 1952. France developed atomic bomb in 1960. China developed atomic bomb in 1964. Other nations pursued weapons programs. Israel developed atomic bombs secretly. Pakistan developed atomic bomb. India developed atomic bomb. Nuclear weapons spread despite international efforts controlling proliferation. By century's end, numerous nations possessed nuclear weapons. International community recognized proliferation threat but lacked enforcement mechanisms. Cuban Missile Crisis brought nuclear war dangerously close in 1962. Soviet Union placed missiles in Cuba, threatening American cities. American military demanded nuclear war. President Kennedy negotiated removing missiles without military confrontation. Nuclear war was narrowly avoided. The crisis demonstrated that nuclear weapons threatened human survival. Both superpowers recognized mutual vulnerability to nuclear annihilation. Subsequent treaties attempted limiting nuclear weapons and preventing accidental war. Nuclear weapons testing contaminated environment. Atmospheric testing dispersed radioactive fallout globally. Strontium-90 and other radioactive isotopes entered food chains. Children particularly suffered health damage from radiation exposure. Public health advocates exposed testing dangers. International pressure forced testing underground. Comprehensive test ban treaty limited weapons testing. However, some nations continued testing and others refused treaty signing. Disarmament negotiations achieved partial success limiting nuclear weapons. Strategic Arms Limitation Talks, SALT-I, in 1972 limited American and Soviet missiles. Strategic Arms Reduction Treaty, START-I, in 1991 reduced nuclear arsenals. Non-Proliferation Treaty attempted preventing weapons spread. However, nuclear weapons reductions remained modest. Thousands of warheads remained deployed. Disarmament advocates demanded complete elimination. Military strategists argued nuclear weapons prevented large wars. Nuclear deterrence doctrine shaped Cold War strategy. Mutually assured destruction. MAD doctrine proposed that nuclear war was unwinnable. MAD proposed that each superpower's vulnerability to retaliation prevented nuclear war initiation. Critics argued MAD represented insane strategy gambling with humanity's survival. However, no nuclear weapons were used in warfare after 1945. Deterrence proponents credited nuclear weapons preventing World War III. Others argued that war avoidance resulted from rational leadership, not weapons. Nuclear accidents demonstrated weapons dangers. Chernobyl nuclear reactor explosion in 1986 killed thousands through radiation and created evacuation zones. 3 Mile Island accident in 1979 nearly caused catastrophic failure. Fukushima earthquake caused nuclear reactor failures in 2011. These accidents demonstrated nuclear technology's risks beyond weapons. Radiation exposure dangers became widely understood. Public opposition to nuclear power increased. However, nuclear weapons remained deployed globally. Cold War ended in 1991, reducing nuclear tensions temporarily. Soviet Union collapse eliminated immediate nuclear war threat. American and Russian leaders signed arms control treaties. Nuclear arsenals declined from Cold War peaks. However, thousands of warheads remained deployed. Russia and United States remained nuclear adversaries. New nations developed weapons programs. Middle East tensions created nuclear proliferation risks. North Korea developed nuclear weapons despite international opposition. Contemporary world retains approximately 14,000 nuclear warheads. Russia possesses approximately 6,500 warheads. United States possesses approximately 6,800 warheads. Other nations possess smaller arsenals. Accidental nuclear war remains possible through technical failures or miscalculation. Terrorist acquisition of nuclear weapons remains existential threat. Climate scientists warn that nuclear war would trigger nuclear winter, global cooling from soot-blocking sunlight. Nuclear war could make Earth uninhabitable for years. Atomic bomb legacy profoundly shaped 20th and 21st centuries. Atomic weapons enabled Cold War's intense tensions. Nuclear weapons remain most destructive human invention. Approximately 130,000 people died immediately from atomic bombs dropped on Japan. Millions suffered radiation sickness consequences. Environmental contamination persists. Psychological trauma affects survivors across generations. The atomic bomb initiated nuclear age that continues defining contemporary civilization. Nuclear weapons remain humanity's greatest threat. Elimination of nuclear weapons remains elusive goal despite decades of advocacy. Military establishments argue nuclear weapons provide security through deterrence. However, nuclear war risks appear to outweigh deterrence benefits. Climate change and resource scarcity increase conflict risks. Nuclear weapons in unstable regions create escalation dangers. International community lacks effective mechanisms preventing nuclear war. The atomic bomb demonstrated science's terrible destructive potential. Understanding atomic bomb history remains essential for preventing nuclear catastrophe threatening human civilization fundamentally.